Hello Fun Nation, my name is James, checking in here with team number 1114 at the first championship. Hall of Fame team Simbotics, just incredible machine year after year after year. We've done it again this year. You know, you guys can play every aspect of this game. Huge funnel, really nice end effector as well. We're gonna dive into this and more on Behind the Bumpers. Here with me to talk about it, we have Hannah, Alex, Joe, and Nick. Let's find out so much more on Fun. All right, Alex, why don't you get us started? Let's talk about some of the mechanical features of the robot. How are you guys scoring so well?
Yeah, for sure. So let's start here from the bottom. With our drive here, this year we're running the brand new WCP X2T modules. We chose these ones because we saw the game, we're like, it's gonna be an elevator, we need the room. So basically, these ones are longer, they're better. Before it would go into here, right? The longer module allows us to just have the elevator. Yeah, so the gearbox on the elevator here for the manipulator itself, put this back here if you want to get in here for a view. So we have this powered off an X44. Originally it was an X60, but we found that that was like overkill for this. We wanted to save as much as we can for the climber when we were adding that on. So we changed it to an X44. It's worked perfectly fine. There's been no issues with it. The first iteration of this, instead of featuring directly from the pinion to the gear, we had it from it was a belt system from the belt to a pulley here, and then another like to this belt here. And we did that originally for backlash reasons of the two belts, but we found that it wasn't really necessary, and we were running into issues of this smaller belt here skipping, so we just changed that out right before our first event to just having it directly to a gear. Moving up to here, for the belt on the pulley itself, we went with belt instead of gear this year, again for backlash reasons. We just wanted this, you know, when we were at the presets or anything, we wanted this to stay exactly where it was, didn't want any movement at all. So we went with belt. The issue with the belt, obviously, is you have to tension it. So this whole gearbox here is on a slide, actually. And if you can't really see it from the camera, but there's two bolts down here that we tighten in order to make sure that this belt here is tight. And this whole gearbox actually can like slide up and down just for the adjustment of the belt here. And I'm gonna pass off to Hannah for the climber that we
So when we want to deploy our climber at the end of the match, we actually use these two linear actuators on our funnel to fold the entire mechanism out, like this. And then our climber will drop down into position. These actuators are powered off PWM. They use a 63-to-1 ratio, which takes about 3 seconds to deploy our climber at the end of the match. Once the climber drops down, we've got these rollers on the front that will pull the cage in. They are powered off one Neo 550 motor off two belts. Again, this is another time where we use twisted belts in our robot just to save some weight and stop us from needing to use another motor. We have these Lexan flaps on the outside of our climber to help pull the cage into the correct position. Before we had some issues with them catching on the outside of the climber. These flaps are made out of Lexan, are designed to be flexible on purpose so that when our climber folds up into our robot, they won't interfere with our elevator or funnel or damage any other components in the robot. Once we've caught onto the cage using the rollers, we have these latches to hold it in place. When we want to unhook at the end of the match, we just fold them back. Then to actually climb, we use this gearbox at the bottom, powered off a Kraken, and this rope. The whole climber mechanism will actually fold up into a robot using the rope as a winch and pull the cage inside. This entire mechanism is on elastics to help it drop into place really quickly, and just uses the rope to pull the climber in.
All right, we're gonna send it now back over to Nick. Nick, can you tell me a little bit more about how your robot's actually moving, and we're gonna actually watch a demo now.
So this is pretty much our starting position for auto. We hold it here so that our manipulator isn't outside the reach of our zone. On top of that, these straps on our funnel are typically held up. So once our elevator moves up to go to our normal scoring position, it'll immediately drop out, which allows us to have that greater area of reach. So this is our intaking position. We have 3 different intaking buttons on the operator controller, 2 of which angle lock to the station, and 1 of which just intakes the robot, so we can actually have a coral inside of us while we're cycling an algae, so we don't have to angle lock and intake the coral at the same time. After intaking the coral, you'll see this is our holding position that Joe talked about previously. This gives us the easiest position to go through any of our 4 coral presets. 1, it just simply moves the elevator up. 2 is going to bring it back down and through the elevator because it's a pass-through manipulator. Going to 3, just again shoots the elevator up and moves the arm slightly back. And then going to 4, it just brings it up and moves the manipulator again. But that traversal position is extremely important to allow us to be able to move to all of those presets freely without interference, like having to first pull the arm out and then move up, which saves us a lot of time within a match. You want to shoot, Kevin? So moving over to our algae manipulation, we have both presets to grab it off the reef. Once we grab it, our algae manipulator goes into a holding state, which draws less current from the motors, so we're not destroying our wheels while we're holding it. Going down to processor, pretty simple. Going up to barge, we shoot forwards. Previously at our last two events, our two district events, we shot backwards, but we found that the spin of the algae actually caused it to bounce out more than we wanted. Since moving to shooting forward, we pretty much never miss coral or algae. Now moving to our climber. As we talked about, first we have to deploy our funnel. This both compresses it down, which gives room for the cage to pass through. Then we have two different states, so this is our normal state. Once the right lights turn red, we are now in our climb mode, which allows our driver to take control of the climber and take it without interference of like accidentally clicking a button, which would completely ruin the climb. That just intakes the cage. We have to have some momentum when driving up to it, because if we just sit there, the wheels will bounce back the cage because of how compressed those wheels are. And then once we have the cage locked in, these two latches up here make it so it never slips out. And then all we have to do is winch it all the way into our robot. Our climber works off a sequence. So first we bring it to this position to ensure that we have the cage fully grasped and it won't slide through this and go into our elevator. Then our driver will drive us to the side, ensuring that the cage's chain will fall through the robot instead of tapping the elevator and losing that tightness we want. And then we do the second part of the sequence once we moved, and that just brings the cage fully into the robot. You see here that the Lexan straps or the Lexan poles here do interact with things like our funnel and our elevator, but the point of making them Lexan is both to save weight and so that it's flexible around our strap, which we aren't using because we don't use our elevator, and our funnel, which gives us that extra lee room we need to be able to pull the cage fully inside of ourselves.
Well, Team 1114 Simbotics, this robot is awesome. I love watching it out on the field, and learning more about it here in the pits is so cool. So thank you so much for taking the time to talk to us today. Best of luck the rest of the championships. You guys are doing awesome. Thank you all so much for watching this episode of Behind the Bumpers. My name is James, signing off.